Alright, hello, this is Mr. Borrego. This is the first slides for the flipped classroom at Anson Jones Middle School, 8th grade. And today we're going to be discussing atoms. So you should be getting ready to take notes, Cornell-style notes. We're going to talk about that in a bit right here. So make sure that you are setting up your paper right now. Remember, it's supposed to look like this. You're supposed to have your topic, name, class period, date. The questions that I'm going to give you in a moment, they're going to go right here on the left-hand column here. On the right side, this is where you're going to take your notes. Afterwards, you are to complete 2 to 3 sentences, alright, summarizing what you just learned. You need to set your paper up like this. Go ahead and pause the video, and I want you to do that now, because the next slide, you're going to have to write down your questions. Alright, so pause the video now. These are the questions that you need to have on the left-hand side. So the topic is the atom. You have 10 questions right here. So make sure that once you have your paper set up, you need to write these questions down on the left-hand column where it says questions. All right. Now let's get started with the notes. The atom. The atom is the building block of all matter. The structure of the atom, okay, now if anything's in yellow, it's probably important. So this is going to be part of your notes. So you might want to be writing that down. You can pause at any time and come back to it. If I'm going too fast, you can go back, rewind, and listen to it again. The atom is made up of 3 subatomic particles called protons, neutrons, and electrons. Now this is just the structure of the atom. Here we have some pictures representing the structure. So in the center you have a house that represents the nucleus. Here you have 2 brothers living inside the house or the nucleus. The first one he's very happy, he's positive. So he's going to be positive proton. The second brother here is kind of like, whatever, I really don't care, I'm lazy. Neutral. So he's going to be neutron, neutral, neutron. And on the outside, you have little poor electro. He's ugly. Poor electro just floating around. He's a stray. So he never goes inside the nucleus. He never goes inside this house. He just goes around and around. Okay, just like this. Now this is a level or an electron cloud. We'll talk about that in a moment. Alright, so just keep in mind that little electro is going to stay outside, wandering around. The nucleus. The nucleus is located again in the center of the atom. And in the center, remember, you have 2 brothers living there. You have positive proton and then neutral neutron here. Again, here's positive, neutral, inside the nucleus. There's the house, okay, so they live inside the nucleus. Now, the number of protons gives us the atomic number. So positive proton here, determines the number of protons, and this number gives the element its identity. So if this positive proton changes, it becomes a new element, and we'll talk about that more in a bit. So the nucleus. The neutrons are found by subtracting the number of protons from the atomic mass. Now I know this is a lot of information, so just be patient. Let's look at this carefully. Okay? The neutrons are found by subtracting the number of protons from the atomic mass. So let's look at the equation. You have the atomic mass, which is the decimal, right? If we're looking at our box here, this is going to be the decimal number. If we round 6.9, we should get 7. So let's think about this as 7 minus 3. So all you're doing is taking the bottom and the top. So 6.49 or 7 minus 3 gives you 4 neutrons. So it's pretty simple. Okay, 7 minus 3 gives us 4 neutrons. That's how we determine the number of neutrons. Remember, the protons, 3, neutrons, we subtract and we get 4. Here's little electrode, electrons. Electrons, again, are located outside the nucleus. So this is highlighted and underlined. It's going to be important. Electrons are located outside the nucleus on energy levels. So each circle represents an energy level. And these energy levels make up the electron cloud. Here we go. There's a little electron floating around. Each circle is a level. Electrons have a negative charge. Negative charge. Again, they orbit or go around the nucleus. They never enter the nucleus. So electron just is a stray dog. He never goes inside the house or the nucleus. He stays out and about. The number of electrons is determined by the atomic number. So we talked about the atomic number being the number of protons, but it's also the number of electrons. Okay? So the number of electrons is determined by the atomic number. Now, what's the difference between an electron and a valence electron? So the valence electrons are the electrons that are located on the outside energy level, or the very outside circle. They are the furthest away from the nucleus. Let's take a look. There is the valence electron. So these three are all electrons, but this one's special. It's called a valence electron. Why? Because it determines an element's reactivity. Alright, so once again, to wrap it up, the house, who lives inside the house, the brothers, we have positive proton and neutral neutron, right? And floating around on these energy levels are the electrons, and then the valence electron here on the outer is the furthest away from the house or the nucleus here, and it determines the element's reactivity. Well, that wraps it up for this first session. Notes. Please make sure you fill in all the notes section. If you need to use the back of your paper, please do so. And we'll see you soon. Thank you.